Myself Harshavardhana CN, Assistant Professor of Mathematics. In our previous session, we learned indeterminate forms of 0 by 0, infinity by infinity and solve the problem. In this session, we are going to learn indeterminate forms of the type 0 into infinity, infinity minus infinity. Solve this type of problems using L'Hospital's rule. Here, the learning objective is we will learn the indeterminate forms 0 into infinity, infinity minus infinity and solve that type of problems using L'Hospital's rule. Indeterminate forms 0 into infinity or infinity minus infinity. To evaluate the limit of the form 0 into infinity or infinity minus infinity, we rewrite the given expression to obtain either 0 by 0 or infinity by infinity form and then apply L'Hospital's rule. That means to apply L'Hospital's rule, differentiate numerator separately and differentiate denominator separately, then apply limit. Here we are going to solve some problems. The first problem, evaluate limit of 1 minus sin x into tan x as x tends to pi by 2. Here if you apply limit, that means apply x tends to pi by 2. In the place of x, put x equals to pi by 2. 1 minus sin pi by 2 into tan pi by 2. 1 minus sin pi by 2. Sin pi by 2 is 1. 1 minus 1, 0 into tan pi by 2 is infinity, which is of the form 0 into infinity. First, we change this to 0 by 0 form. That is, we know that 1 minus sin x right as it is, tan x is done by cot x. Then this problems become 0 by 0. Therefore, 1 minus sin x divided by cot x. If you put x equals to pi by 2, 1 minus sin pi by 2 is 1 minus 1, which is nothing but 0, by cot pi by 2, 0. Apply L'Hospital's rule. Limit of differentiation of 1 minus sin x is minus cos x and differentiation of cot x is minus cosecant square x. Therefore, limit of x tends to pi by 2 minus cos x divided by minus cosecant square x. Put x equals to pi by 2 minus cos pi by 2 is minus 0 divided minus cosecant square x is minus say 1 0 by 1, which is equals to 0. Second problem, evaluate limit of x into log of tan x as x tends to 0. Here the x apply x tends to 0, 0 into log of tan 0. Tan 0 is nothing but 0. Log 0 is minus infinity. 0 into minus infinity. Therefore, which is of the form 0 into infinity. First, change this to 0 by 0 or infinity by infinity form. In this case, we write like this: log of tan x right as it is. This x can be written as 1 divided by x. Then the problem becomes, suppose if we put x tends to 0, log of tan 0, that means log 0, which is nothing but infinity, divided by minus infinity, divided by 1 divided by 0, infinity. This problem becomes infinity by infinity form. Apply L'Hospital's rule, which is equals to limit of x tends to 0. Differentiation of log of tan x is 1 over tan x into secant square x. Differentiation of 1 by x is minus 1 by x whole square, which is equals to, simplify this, we get minus x square secant square x divided by tan x. Split this into x into minus x secant square x, numerator will become like this, divided by tan x. The value of this is 1. And limit of x tends to 0, x into secant square x, which is equals to 0 into secant square 0, 1 square, 0 into 1 square, 0. Therefore, 1 into 0, the total value is 0. Next, we are going to solve limit of secant x minus tan x as x tends to pi by 2. Here x tends to pi by 2 means put x equals to pi by 2, which implies secant pi by 2 minus tan pi by 2, which is nothing but secant pi by 2 is infinity minus tan pi by 2 is also infinity. Therefore, this problem is in the form infinity minus infinity. But here first we reduce this into 0 by 0 form, then only apply L'Hospital's rule. Therefore, this problem equals limit of secant x is 1 divided by cos x and tan x equals to sin x by cos x. Therefore, limit of x tends to pi by 2, 1 divided by cos x minus sin x by cos x. Taking cos x as LCM, we get limit of x tends to pi by 2, 1 minus sin x divided by cos x. Definitely 1 minus sin pi by 2 minus cos pi by 2 equals to 1 minus 1 divided by 0, 0 by 0, which is 0 by 0 form. Apply L'Hospital's rule, that is differentiate numerator and denominator separately with respect to x. Therefore, limit of x tends to pi by 2. Here differentiation of 1 minus sin x, differentiation of cos x is minus sin x, which is nothing but minus cos x by minus sin x cot x, cot of pi by 2. Apply limit cot of pi by 2, cot of pi by 2 is equals to 0. This is the value of our limit. Next, fourth problem. Evaluate limit of x tends to 0, 1 divided by x square minus 1 divided by x tan x. Put x equals to 0, 1 divided by x square, 1 divided by 0 minus 1 divided by x tan x, 1 divided by 0, which is equals to infinity minus infinity form. First reduce this to 0 by 0 form, then apply. First, which is equals to taking x square tan x as LCM, this problem becomes limit of x tends to 0, tan x minus x divided by x square tan x. Before going to solve this, we made an adjustment which makes our problem very easier, which is equal to limit of x tends to 0, tan x minus x divided by x cube. Here multiply and divided by x. Therefore, here x cube into x divided by tan x. But we know that limit of x tends to 0, x by tan x equals to 1. This value becomes 1. Therefore, the problem becomes limit of x tends to 0, tan x minus x divided by x cube. Next, which is equals to limit of x tends to 0, tan x minus x divided by x cube, tan 0, 0 minus 0, 0 divided by x cube, 0 cube 0, 0 by 0 form. Apply L'Hospital's rule, which is equals to differentiation of tan x is nothing but secant square x, differentiation of x is 1 divided by x cube is 3x square, which is equals to 1 by 3 limit of x tends to 0, secant square x minus 1 tan square x divided by x square. The limit of tan theta by theta, theta tends to 0 equals to 1. Therefore, this is nothing but 1 square, 1 by 3 into 1 square, definitely which becomes 1 by 3. This is our solution. Next problem, evaluate limit of x tends to 0, 1 divided by x square minus 1 divided by sin square x. Here put x equals to 0, 1 by x square is by 0 square minus 1 by sin square 0, which is equals to 1 by 0 minus 1 by 0, which is the infinity minus infinity form. First, we reduce this into 0 by 0 form by taking x square sin square x as LCM. Taking x square sin square x as LCM, the problem becomes limit of x tends to 0, cross multiply sin square x minus x square divided by x square sin square x. Definitely, sin square 0 is 0 minus 0, 0 divided by 0, it becomes 0 by 0 form. First, we make an adjustment, multiply and divided by x square, we get which is equal to limit of x tends to 0, sin square x minus x square divided by x to the power of 4, here multiplied by x square by sin square x. That we know that limit of x by sin x as x tends to 0 equals to 1. Therefore, limit of x square by sin square equals to 1 square. This value becomes totally 1. Therefore, the problem becomes limit of x tends to 0, sin square x minus x square divided by x power 4. Put x equals to 0, which becomes 0 by 0 form. Apply L'Hospital's rule, which is equals to limit of x tends to 0, differentiation of sin square x, 2 sin x into cos x minus differentiation of x square is 2x divided by differentiation of x power 4 is 4x cube. Next, which is equals to limit of x tends to 0, 2 sin x into cos x is sin 2x. Use here sin 2x minus 2x divided by 4x cube, which is definitely 0 by 0 form. Apply L'Hospital's rule, which is equals to limit of x tends to 0, 2 cos 2x, differentiation of sin 2x is 2 cos 2x, minus 2 divided by 12x square. Again, if put x equals to 0, cos 2 into 0, cos 0, which is nothing but 1, 2 into 1, 2, 2 minus 2 divided by 0, definitely which is 0 by 0 form. Again apply L'Hospital's rule, which is equals to limit of x tends to 0 minus 4 sin 2x divided by 24x, which is again 0 by 0 form. Again apply L'Hospital's rule, which is equals to limit of x tends to 0, differentiation of this is minus 8 cos 2x divided by 24. Substitute x equals to 0, therefore minus 8 into cos 0 by 24 minus 8 by 24, which is equals to minus 1 by 3, because cos 0 equals to 1. This completes the problem. Next, evaluate limit of x tends to 0, 1 divided by x minus 1 divided by e power x minus 1. Put x equals to 0, which becomes 1 by 0 minus e power 0 is 1, 1 minus 1, which equals to 1 by 0 minus 1 by 0, which is equals to infinity minus infinity. First reduce this into 0 by 0 form. Next, which is equals to limit of x tends to 0, take x into e power x minus 1 as LCM, which becomes e power x minus 1 minus x divided by x into e power x minus 1. Put x equals to 0, we get 1 minus 1 minus 0 divided by 0 into 1 minus 1, again which is 0 by 0, 0 by 0 form. Apply L'Hospital's rule, differentiation of numerator is e power x minus for 1 0 x 1 divided by, apply product rule, first function into second function. First function x, differentiation of second function is e power x minus 1 into differentiation of x is 1. Apply x equals to 0, again we get 0, numerator e power x is 0 minus 1, e power x, e power 0 minus 1, 1 minus 1 divided by 1, 0 plus 1 minus 1, 0 by 0 form. Again apply L'Hospital's rule, we get which is equals to limit of x tends to 0, e power x divided by x into e power x plus e power x plus e power x. Put x equals to 0, e power 0 is 1 divided by 0 into 1 is 0, 1 plus 1, which is equals to 1 by 2. Here I given some exercises, solve this by above method. It's very easy. Here the session outcome is we will be able to solve the problems on indeterminate forms 0 into infinity, infinity minus infinity types using L'Hospital's rule. I referred the textbook Differential Calculus by Shantinarayan, P.K. Mittal, a textbook of BSc Mathematics by G.K. Ranganath, textbook of Mathematics BSc second semester by Professor G.B. Gururajachar, textbook of BSc Mathematics by B.V. Manjunath and Dr. C. Nandish Kumar. Thank you one and all.